You remember Jack and Drakes is the winner of the ISEF 2012, and this year ISEF, the competition for young scientists promoted by Intel, has been won by a project of a self-driving car, a low-cost self-driving car, and let's take a look at the clip first.
The winner of the $75,000 Gordon E. Moore Award in the category of Computer Science from Ranicu, Valseu, Romania, Ionut Budisteanu.
I can't. Yeah, thank you.
Let's get ready for that.
I'm working to a self-driving big car, but a very cheap one. Why self-driving car? A self-driving car is an autonomous car which should be able to drive automatically in the urban areas without any driver. Okay? The idea is that road traffic injuries caused 2.5 million deaths in the last years and more than 50 million injured just in 1 year. And a study using British and American crash reports as data found that more than 87% of traffic accidents were due solely to driver factors. Building self-driving cars will reduce the number of deaths very exponentially. But 1 year ago, I graduated 2 online courses about self-driving cars made by the Stanford University professor, Sebastian Tran, who actually built the Google self-driving car. I was amazed that Google self-driving car just drove about 500,000 kilometers without any accident. So I decided to create a small part of my self-driving car, maybe a Romanian high school student version, because I'm not a university. After working a few months on my project, I got a small problem, I think a very big problem one. The current autonomous car problem is caused by using a very expensive 3D LiDAR, which costs $75,000, and it is used to recognize the environment, to create a high-resolution 3D map about the environment and in order to avoid the obstacles. This is the only 3D LiDAR that is good enough for self-driving cars. It is made by Velodyne. It costs $75,000. It's HDL32E. And you can see that many other self-driving cars, like Volkswagen, like BMW, like Ford, like General Motors, like Google self-driving car, are using the same one. Initially, I was looking for different ways. I was just thinking about how to remove the 3D LiDAR. Maybe I can use artificial intelligence. Maybe I can use image processing to reduce the entire of the 3D LiDAR. I built a software to recognize from images vehicle with a vehicle detection based on artificial intelligence and particle filters. But the problem was the recognition was about 70%. That means in 1 year, there will be millions of cars that cannot be recognized by the software. So that means you cannot build just the software in order to make a self-driving car. So actually, I was looking to create my own 3D LiDAR. The 3D LiDAR is a device that is spinning like a radar and creates a 3D map. It is used by the car to take a decision to avoid obstacles. Okay, so my project right now, it is my solution and my project is a minimal 3D LiDAR with a resolution of 1 megapixel per second that will maximum cost $4,000. And 3 special cameras mounted in the driver position and left and right side of the car in order to recognize the traffic lanes, traffic sinks, and to calculate how to change the steering wheel in order to maintain the car on the center of the street. So this is the software. This is a diagram about my self-driving car. There are about 5 different laptops processing. There are parallel and distributed algorithms that use artificial intelligence to recognize traffic sinks, traffic lanes, to calculate exactly or using probabilities the position of the car on the road, where the road sides are, and to propose a new direction of the car, even in the absence of the traffic lanes. The software processes the data from the 3D LiDAR and create a 3D map using OpenGL. Using GPS coordinates and particle filters, I'm able to localize the car on the road and I'm making a global database with all of the traffic sinks in order to improve the quality of recognition of the traffic sinks. I'm processing the data from the acceleration sensors, a distributed software, supervisory system, software which drives the stepper motors to turn the steering wheel, acceleration, and braking. Okay, the traffic lane detection, it is based on particle filters and AI. And it is able to compute the distance between the lanes and probability of how close are the car steering wheel in order to turn in the different direction in order to maintain in the center of the street. So this is the software that it was able to recognize the traffic lanes and also other software and other parts. This is a simulation. I did about 40 different simulations through my small city in Romania, Râmnicu Vâlcea. The simulation were offline. That means I recorded the data from the GPS, from those 3 different cameras, from the 3D LiDAR that was spinning about 20 times per second, and 5 laptops inside of the car, and I was recording the data to see how the software thinks. Why I didn't do real-time simulation. The 3D LiDAR that I built, the first generation I call it, it is only $200 right now. It is not good enough for real self-driving cars. And this is the traffic sync software based on color filtration artificial neural networks. It is able to recognize all of the traffic syncs. But there is a small problem with that one. Sometimes the detection of the traffic syncs cannot be done accurately because there are obstacles such as trees or trucks, and it may cover the traffic syncs. Also, all other self-driving cars, they have the same problem. And I did a different approach, saving in a global database. So the idea is to avoid and to increase the traffic sync detection. All autonomous cars collaboratively will try to create a common database and communicate each other using a database and internet. This was the software that I made a simulation with the traffic syncs and creating the global database with the traffic syncs. Okay, this is the first version of my 3D LiDAR. It cost only $200, but it has a resolution of 18,000 pixels per second, and it is used, as I told before, that it is to make a decision in order to avoid obstacles. It is something that is spinning all of the time, about 20 times per second. This is a screenshot, a picture of my 3D LiDAR of $200 one. The technology, it is quite different with Velodin one because the technology evolved. They designed a 3D LiDAR in 2007, but it is not about $75,000 to produce, so Velodin doesn't produce the 3D LiDAR with $75,000. They have a monopoly based on their project, based on their 3D LiDAR. And this is a Fiat that I was tested. It was my father's cars. So the simulation was my dad was driving the car. I placed the 3 different cameras, the 3D LiDAR. I was with 5 different laptops inside. I was recording the data. And after that, I was just checking of how the system is working, how take decision in order to avoid different objects, in order to take to left, to turn to right, or something like that, in order to maintain the car on the center of the street. For instance, if it sees that it's approaching to the left lane, the car is approaching to the left lane, then automatically change the steering wheel in the opposite direction in order to maintain in the center of the way. This is the software that it is able to recognize from it is able to read the data. Actually, first version, it is just using RS-232 and receive the data from the 3D LiDAR. And I'm using OpenGL to create a 3D map. That software to create a 3D map is required for debugging and to see the obstacles, because actually the software is quite useless to use an OpenGL software in order to have the same data 2 times. So this is the software that it is able to create a 3D map about the obstacles. This is only about 18,000 pixels with a $200 3D LiDAR. But the problem of this 3D LiDAR that I built, it is that it is not able to recognize small objects. What I define small objects? Like, for example, dogs or different holes or different objects, and it is able to recognize vehicles with about 100% recognition, houses, buildings, trees. It is not able because they are quite tight, so it is not able right now. And the people, it is quite a very big problem with my $200 one. The people from 10 meters, it is able to recognize. But after 10 meters, it is not able because the resolution is very low. So now I'm trying to design and to finish my high-resolution 3D LiDAR. It will have almost the same resolution in the Velodin 3D LiDAR, about 1 megapixel per second, but will maximally cost $4,000. It is quite a different approach of how to design the electronic board. I used the cadence worker to simulate, computer simulate everything, even how the 3D LiDAR is working over there. And this is just my approach of how to buy us very expensive stuff, just building it in your homemade. The idea is to use the time of flight. It is based on reflection of the photons from the object, and the photons just go with the speed of light, and I'm just able to calculate the distance between the object and the 3D LiDAR. And there is also, because there are distributed algorithms and parallel algorithms, for me it was cheaper, for a high school student, it was cheaper to buy many different laptops and to just use those laptops to process different tasks, and to use a master software, a supervisory one, and to collect the data and to obtain the final decision. So this is why the master software is able to do. Also, it was quite strange and hard to go to all of the laptops and turn on and open all of the software and all of the algorithms. So I'm using the supervisory system to turn everything on. And the project status is about 80%. Now I'm trying to work with several companies in Romania to create, to put the self-driving car on the road, also to control the steering wheel by the car, by the software, so a real-time simulation. And I'm trying to finish until May and April. I'm trying to work with Romanian car manufacturing, maybe with Dacia or Renault. And this is my homemade laboratory where I build my projects. I'm working for about 8 years. Since 5th grade, research and programming are my life. I've been in about 50 different projects. I'm very happy that this year, after four Intel ISEF competition, I just won the Grand Award. I'm very, very excited, and I was unprepared to receive such thing. And the question, if there will be in the future self-driving cars, the answer it is not correct. I mean, the question is not correctly. There must be a question when there will be. There will be in 5 years. Not all of the cars will be self-driving cars, but a lot of them will be self-driving cars, because it is quite inexpensive. My calculation is about 5,000 euros or 6,000 euros to create from a simple car a self-driving car, and without. And in the end, I want to tell you that I was born in the city which is the cybercrime capital of the world, and it is also called Hackerville. Unfortunately, all of the children in my town dream to become hackers, to do scams, to hack different agencies like NASA, do phishing. And but now, after winning the Gordon E. Moore Award, I heard with astonishment that the children in my town, in my neighborhood from Hackerville, they no longer play like hackers. They want to be like me. They want to do research, and maybe one day they will change the world. And I'm very proud of this, and I'm very proud that, my little science fair project that I just went to Intel ISEF this year, and I was able to change something and to do something positive in my country, in Romania. At my suggestion, the Minister of Education, the Prime Minister, created a program called the Ionut Budisteanu Scholarship, consisting of 50 different scholarships for 50 students who want to do research about 15,000 euros. And I'm very proud of this, because everybody from Romania, they just told me, you cannot change the system. And just at 19 years old, I was able to change the system. And I want to thank to Intel that it gave me the chance. It gave me the chance to inspire and to motivate many young people, in particular Europeans, who understood that only through education and hard work they can succeed in life. Thank you very much.
Bravo. Love the story. Thank you.
Thank you
so much, Ionut.